Hello, in this video we are discussing combining functions symbolically, and we're going to focus on addition, subtraction, multiplication. So when you're working with functions and you are either adding or subtracting or multiplying, you need to first worry about the algebra that's involved, but you also have to worry about your domains. So let's talk about your domains here at the very beginning. This is a quick little blurb that helps you to understand what I'm talking about with domain, and that means you have to take what we call the intersection of the two domains. So if I have a function, let's say f of x, that has a domain of bracket 4 to infinity, and then if I have another function, g of x, that has a domain of negative infinity to 5 parentheses, if I add, subtract, or multiply those two functions, I have to take the intersection of the two domains. So let's just say I'm finding f plus g of x, which would be where I add the two functions together. So I suggest that you graph these on a number line and maybe use different colors. A lot of students like doing that. The different colors help to see the intersection. So if I do f of x in red, so I would have 4 with a closed circle, or you could put a bracket there, and then I would be going to the right. Okay. And then if I have my g of x function, I'll switch to a different color. I'll use green. And that is an open circle. So imagine an open circle at 5 and going to the left. Okay. My intersection of the two domains will be where these two domains overlap, which is going to be right through here. But be very careful with thinking about the brackets and the parentheses, because I can include the 4, but I must use a parenthesis on the 5. And this would be my domain of the combined function where I added f plus g of x. So you always want to think about using the intersection, and that's where your domains will overlap or have those common elements. So let's do some problems together here. And we're given two functions, f of x and g of x, and we want to first find the domain of f plus g and f minus g. So you want to think about your domain of f of x, and you want to think about your domain of g of x, and then we'll put those domains together. So f of x is a quadratic function, and we know those look like a u, right? That parabola, we've already studied that. And our domain for this one is going to be all real numbers, which is negative infinity to positive infinity. And for g of x, that's a square root function, so it's going to have this look to it where it shoots off to the right there. Okay, you maybe want to put that on Desmos if you're having a hard time thinking about that graph. And my domain for that particular function is going to be bracket 2 to infinity. So when I think about the overlap between these two functions, it's going to be this right here, this bracket 2 to infinity. So for part A, my domain of the combined function is going to be bracket 2 to infinity. So for both of the addition and subtraction, the domain works the same. You just find the intersection between the domain of f and g. So for part B, we need to find the actual f plus g, and that's where we're going to add those functions together. So we're going to take f of x and add it to g of x. Well, f of x is x squared minus 1. And I'm going to add that to g of x, which is square root of x minus 2. And here's where you would do any simplifying if that's applicable. But for this particular example, there's nothing that can be simplified, so that is your answer. For f minus g, we're just going to subtract the two functions. We're going to do f of x minus g of x. F of x is x squared minus 1. Subtract, g of x is square root of x minus 2. Simplify if applicable. In this case, nothing simplifies, so we're done. So when you're finding the product of two functions, you are multiplying the functions together, and the domain is the intersection, just like what we were just working with. So it works the exact same way as the addition and the subtraction. So let's do an example here. So part A is find the domain. So first we want to think about our domain of f of x. So f of x is a square root function, and you can look at that on Desmos if you want to, but we've also talked about how the inside of that square root must be greater than or equal to 0. So here's where algebraically you may want to do a quick calculation, and you solve your inequality, and that will tell you your domain. So my domain is x is less than or equal to 3, which is going to be parentheses negative infinity to 3 bracket. For g of x, I have a rational function. So we've talked about with rational functions, the denominator, what's in the bottom of that function, cannot equal 0. So I'm going to factor the bottom of that function, which factors to x plus 5, x minus 5. So we have a difference of squares, and then we can set each of these equal to a not equal equation. So we can say x plus 5 cannot equal 0, which means x cannot equal negative 5, and x minus 5 cannot equal 0, which means x cannot equal positive 5. So now we know for g of x restrictions on x. Okay, so now we need to put our domain of f of x together with our domain of g of x. So first I usually mark my restrictions. So I have a restriction at negative 5 and 5, and those will be open circles. I'll put an open circle here and an open circle here, and that's my domain of g of x. For f of x, change colors here. I'll do that in green. I want to have a bracket at 3, which will be a closed circle, and then shade to the left. But make sure you skip over the negative 5. And then we want to look at the intersection of these two graphs. So we're looking for what can my domain be with taking into consideration what f of x needs for its domain and the restrictions on the g of x domain. So, and let me just say a quick note here. For g of x, you can have any other x values. You just can't have negative 5 and 5. So we can also have values this way. We can have values in here. We can have values here and values this way. Okay, we just can't have 5 and negative 5. Okay, so if you think about your overlap between the two function domains, you're going to have negative infinity to negative 5 parenthesis union negative 5 to 3 bracket. And this is your domain for the product of f and g. So this is the answer to part A. For part B, we're going to actually compute the product. So I'll do that up here, and I'm going to take my f of x and I'm going to multiply it to my g of x. Well, f of x is square root of 3 minus x. I'm going to multiply that to g of x, which is 1 over x squared minus 25. When you multiply these two functions, you can think about this as being over 1. And you multiply numerator times numerator, which will just give you square root of 3 minus x. And denominator times denominator, which will give you the x squared minus 25. And you would do any simplifying if applicable, but nothing that will simplify for this one, so this is our answer. So if we move on to the next problem, we are given f and g in a table format. So this first table here is your f of x function, and the second table is your g of x function. And they want us to compute f plus g, f minus g, and f times g. Right here, this is the same as f times g. If they want to leave the dot out of the middle, that's fine. So I want you to see if you can figure this out on your own. For f plus g, you should be adding your outputs together. For f minus g, you should be subtracting your outputs. And f times g, you should be multiplying your outputs. So pause the video and see if you can figure out the answer to each of those computations. Okay, so I have put the answers to each of those parts. So I'll just talk you through a little bit of it here. So when I found f plus g, I took my output of f and I added it to my output of g, and that was my new output. Notice that my x value stayed the same, -2, -2, -2. And then you just continue for each of those x values and each of those outputs. All right, for my, whoops, I erased a little too much there, but that's okay. For my f minus g, I just subtracted my outputs. I took my output of f, output of g, and I subtracted. So I'm doing -1 minus 4, which gives me a -5. And I continued that for the entire table. Okay. And then for my f times g, the same idea. I took my output of f, multiplied it to my output of g, and that's my output of f times g. Once again, notice that the x values stayed the same. So if you had to give your domain, all right, if you had to give your domain for each of these, the f plus g, the f minus g, or the f times g, you would just list those x values that you're working with in the table. And a lot of times we will use a set notation to list those. And if you had to give your range, we don't do much with range with these, but if you had to give your range, you would just list these y values for each one. You would have to do the range separately for each one because the range does change because of the different outputs, but you would just list out those values as your range. Anyway, I hope you are having success with this. If not, post questions and I'll see you online.